Hello everyone, and welcome to the NEATEC Electronics Series. This episode is about the bipolar junction transistor. So let's get started. Alright everybody, so I want to talk about one last concept, and it makes use of a theorem called Thevenin's Theorem. Okay? Now, Thevenin's Theorem basically provides a method for simplifying a circuit into a standard equivalent form with respect to two output terminals, okay? So you can use it to simplify complex circuits, all right? It's a very useful thing to know, all right? So basically, there's two things you want to know. You want to have a Thevenin voltage, and you want to have a Thevenin resistance, okay? We call this VTH. That's TH obviously stands for Thevenin, right? So this is in no load. This is voltage across your 2 points that you're using with, I'm going to say, no load. And when I say no load, I'm talking current, okay? So it has infinite resistance, okay? The other one we got to talk about is R Thevenin, right? And this is the total resistance between those two terminals, right? However, this is the thing. The sources of your voltage replaced, right, by, and this is going to be by the internal resistance of the source. Of source. Now, man, that was long, wasn't it? The thing is, most times when you're looking at a circuit, you're going to approximate the internal resistance as 0, okay? So generally, if you have a short, when it comes to it, you're just going to take it, you're going to just use a wire between where your source used to be, right? And many times the source is just connected to ground, so it's just a short to ground. Now we're going to use these two concepts next when we simplify a BJT amplifier, okay? Okay, see you shortly. Alright everybody, so why don't we draw a voltage divider bias for a BJT amplifier. And we're going to make this real simple, okay? So here is your VCC. Let's bring it down. We're going to go through your resistor, bring it down. Here's your collector. Here's your emitter. Your emitter resistor. There's ground. This is RC, and this is RE. Here's your base, and we're going to have your voltage divider right here, right? Let's connect this one over here. Comes up here, and then this comes down here, and we're going to connect it right here. All right, and we simply are going to call this one R1, and we'll call this one R2. All right, So first, let's just take this, let's let's move it to the left and let's just talk about what's going on, right? So you know you have an amplifier here, and basically this voltage divider is applying this voltage divider. When I'm talking about that, what I'm talking about is this right here. These two resistors, right, in series, and you're tapping off the center right here. Voltage divider. You have VCC up here, and you have a lower voltage. In this case, we have ground down here. All right. So depending on these resistor values, is going to be your base voltage. So if you remember, okay, if we're going to look from your base, suppose we are standing right here. I'm going to use a different color for this one, all right? Suppose we're looking out this way. If there's your eye and you're looking out this way, right? And we want to see the voltage coming in. Let's redraw that, right? In other words, you don't care about the transistor, all right? You don't care about this right now. We just, if you forget about all that, you're just looking here, you disconnect it. If you disconnect it right here, all right, this is connected to VCC, this is connected, and down here, I'm looking, all right, this is connected to ground, so this is connected to ground. What voltage would you see? Well, basically, if we're going to calculate it, your Thevenin voltage, you already know this, is simply going to be R2 divided by R1 plus R2, right, times VCC, right? Now that's pretty straightforward. You're used to that, right? Remember, disconnected, no current flowing, that's going to be your voltage there, right? Now, let's talk about this. What about our Thevenin, right? Okay, so let's redraw this. If you redraw this, you're going to have VCC. You're going to come down here, right? Boom. Come down. Here's your collector. Here's your emitter. Emitter resistor. Ground. This will be RE for your emitter resistor. This will be RC. Now, here's your base, right? And remember, we're looking that way, okay? That means we're looking out this way, okay? So, at this point, remember the rule? You have this part. Remember we went from here, we went up through this to VCC, all right? Remember, these two were simply connected, all right? So now I just disconnected them, but they're still connected to VCC, all right? Now, think about it here. That VCC, what did we say you have to do with our Thevenin? It's replaced by its internal resistance, isn't it? So if we come up, right, then we're going to through VCC, and we're going to assume it's 0. So that's just a wire. And the other part is just simply going to go, I drew that over, it's too far, I'm sorry, it's just going to go to ground, right? So really, if we want to redraw that, and that's what I'm going to do right now, I'm just going to redraw for you, all right? To make it simpler, right? We could simply draw that as a resistor. Now we're talking about R1 here, coming out. R1, we're going through your source. To ground, got it? And then your R2 is going to be going to ground over here, isn't it? This is R1. this is R2. Let me move that over a little bit and put that right where I'm going to put the resistor, right? Move it over here. And let's draw it now. And you come here. There you go. R1 and R2. All right, we just basically redrew it, right? So if you want your Thevenin resistance, you see that these two resistors are in parallel. When I say these two resistors, I'm talking about R1 and R2, aren't they? So really, you could even simplify that further, couldn't you? So why don't we do it? I'm going to redraw it again for like a third time, but I think this is good to explain it. So I'm just going to take this right here. Okay, I'm going to get rid of it. Really, if we draw it again, we can simply say, let's just take this R1 over here. I'm sorry, R1. R1. This is going to go through your source, which is just a wire, to ground. Now, these two resistors, R1 and R2, are in parallel, aren't they? R1 is in parallel with R2, aren't they? Well, guess what? If you're looking out, right, and from remember, we're going to, if you sever this right here, you sever it, you're just looking out. What's the resistance? Guess what? That's going to be R1 in parallel with R2. This is going to be R1 parallel with R2. Okay? So, you have just simplified it. Now you know your Thevenin voltage, and now you know your Thevenin resistance, right? So, if you want to, let's redraw this again, and this may be the last time, right? Although I'm not going to promise you that. I'm just kidding. So, actually, I'm not kidding. I think this will be the last time, okay? Come down. My lines aren't as straight. I'm going fast. So here's your RC, right? Here is your RE for your emitter, your collector, VCC, right? So really what you have coming into your base, because now we know what VTH is and we know what RTH is, we can say, all right, well, we have VTH, that's our equivalent voltage, going through a resistor, RTH. Okay? That's basically your equivalent circuit, right? So think about it right now. And what I'm going to do here, I'm going to have to take this, okay? I'm going to have to take this area right here. This is what we ended up with, right? But if you start from here, right? Let's start from here. What are we gonna have here, right? So think about it. If we go down this way, we're gonna start with VTH, that's your Thevenin voltage, right? You're gonna subtract, right, the voltage across your Thevenin resistor, right? You're going to subtract your voltage from your base to emitter. So remember, we got a voltage drop here, we got a voltage drop here, and we have one more. Voltage drop across RE. Get it? That must equal 0. It has to, right? Because you're ending up right here at ground. Got it? Remember, you started right here. That's your positive voltage. You're going to have a voltage drop here. You're going to have a voltage drop here. And you're going to have a voltage drop across RE. And then it has to equal 0. All right? So, basically now, if we rewrite this, let's just pull VTH on one side and put everything else on the other side, okay? So this will be VTH equals what? VRTH plus VBE plus VRE. Got it? Makes sense, right? Because this is the only positive thing. Everything, these items here, when you subtract it from VBE, VTH has to equal 0. So therefore, they have to equal each other, right? So let's just think about it now. Let's just rewrite this now and say what we know using Ohm's law. This is going to be equal to what? This is going to be equal to your base current, IB, times what? RTH. Get it? VBE is going to stay the same, right? And what's this going to equal? Well, that's going to equal IERE. Get it? Now, I'm going to do a change here for this variable, okay? Because we know, where will I write this? Let me write it over here. We know IB is equal to, basically going to be equal to IE divided by beta. If you recall, remember IB, I just do it right here. IB times beta equals IC, which is approximately equal to IE. Get it? So IB times beta equals IE. If you divide both sides by beta, these are going to cancel out, and this is what you get, okay? So let's make that substitution, right? If we just substitute it, we have what? IE divided by beta times RTH plus VBE plus IERE. Okay, get it? So what do we know? These two terms, this term and this term, both have IE in it, right? So let's just get those together. And we'll put this off to the side, okay? So we'll say this is going to equal to what? IE times, it's going to be, we can bring RE, well, we'll just keep it like it is. RTH over beta plus IE, right? That's an E there. I'm sorry, I'm writing kind of fast. Plus VBE, right? Now, let's do something here. Let's change these. Let's reverse them this way, okay? Okay? So, you know what, I'm sorry. This is an RE. That's RE. That's my fault. I'm sorry. This is what we pulled down here. This RE is what we're right there. So if we reverse this, just reverse these two terms, we have IE times RE plus RTH divided by beta plus VBE. Got it? Now, and this is all VTH, right? VTH in VTH. Now, I'm going to rewrite this over here. If we can then solve for IE, right? Let me just rewrite this up here for you so you can follow it. So we'll have VTH equals IE times RE plus RTH over beta, right, plus VBE. Now, we want to have IE by itself, right? So how are we going to do that? Well, we could divide. First thing we're going to do is subtract VBE from both sides, all right? So we will have VTH minus VBE. You see, if you subtract VBE from both sides, this VBE goes away, doesn't it? Right? It would go away. Got it? Then you'll have V minus VBE equals IE times RE plus RTH divided by beta. Okay? Now, then we want to divide both sides by this quantity right here, right? So now we'll have VTH minus VBE divided by divided by RE plus RTH divided by B equals IE. Got it? So let's look at the forest between the trees here. We're looking for this current right over here, right? This is the current we're solving for, right? IE. Well, this is IC is approximately equal to IE, right? That's what I wrote there, IE. How do we usually get it? We take this VE, whatever it is, VE, and we divide it by RE. What's VE equal to? Well, VE, right, is simply going to be your VB minus VBE, right? Remember, this is your 0.7 drop here, and this is your base voltage. That's going to equal VE, and it's divided by RE. Get it? That's what we learned in the prior video. If you compare both of these equations, they're very similar, aren't they? VB is the same as VTH, right? It's the same value, okay? VBE, we have a VBE here, we have RE, but notice that term right there. That is missing, isn't it? Okay? So in this method, when you use this method, you have RTH over beta. But since beta is usually a large number, this is very close to, it's a very small number. So we assume it to be 0. And that's how we come up using this. All right? I saw this and I just couldn't let it go because I wanted to show you this method and how it relates, because you're going to hear about Thevenin again if you're interested in electronics, which I assume you are since you're watching this video, maybe even taking this class. All right, everyone. Thank you. Bye now.